The leave schedule of our room specialist has coincided with a groundbreaking revelation. The deployment of our $101 billion technological marvel is paving the way for unprecedented exploration. If all goes as planned, we're on track to initiate our journey toward Proxima b, a trip expected to take approximately 20 years. However, it may be several more years before we can truly determine if life exists on that distant world. The search for extraterrestrial life continues, powered by the extraordinary capabilities of the James Webb Space Telescope, JWST. This next-generation observatory has already uncovered remarkable phenomena far beyond Earth, clues that may bring us closer to answering humanity's age-old question. Are we alone in the universe? From the beginning of recorded history, humans have questioned their place in the cosmos. Our curiosity, paired with a sense of existential solitude, has driven us to search for other intelligent beings. This quest is deeply rooted in our culture, reflected in countless scientific theories and media portrayals. And now, we may be closer than ever to answers, but are those answers what we truly want, or will they only deepen the mystery? Join us as we explore the cutting-edge discoveries in exoplanetary science. We stand at the edge of an era that might lead us to confront truths we are not yet prepared to face. In 2021, the launch of the JWST marked a monumental milestone, potentially one of the most significant scientific achievements in history. Around the same time, scientists pose a provocative question. Could future telescopes detect artificial lights on distant exoplanets, such as Proxima b, the closest known exoplanet to Earth at 4.25 light-years away? Proxima b is a tidally locked world, meaning one side always faces its star, while the other remains in perpetual darkness, much like our moon. A theoretically advanced civilization could harness solar energy from the illuminated side using photovoltaic cells and transmit it to the dark side. A study co-authored by Manasvi Lingam and colleagues explored this possibility, suggesting that future telescopes could detect the signature of such energy usage. Thanks to the upgraded capabilities of the JWST, we've been able to extend our search for artificial illumination. In 2024, the telescope detected what could be these very signs of light, an extraordinary achievement that could signal the dawn of a new era in space exploration. Let's take a closer look at how such a discovery became possible, and what it means for our understanding of the universe. With every technological leap, we edge closer to answering fundamental questions. Who are we? Where do we come from? And where are we headed? While philosophers might argue we're still in the early stages of understanding our cosmic significance, astronomers are increasingly optimistic, thanks to ever more sophisticated instruments that are unlocking the secrets of the stars. The James Webb Space Telescope is one of these revolutionary tools. As an infrared observatory, it was designed to explore the deepest corners of space and time. Its mission is to help answer some of the biggest questions ever asked. Are we alone? What is our purpose? Where are we going? One of JWST's key observational targets is Proxima b, also known as Proxima Centauri b or Alpha Centauri b. Classified as a super-Earth, this exoplanet orbits an M-type red dwarf star. If you're unsure what a super-Earth is, don't worry. This article will explain everything. Super-Earths, exoplanets, and the search for life. Why Proxima b captivates astronomers. Super-Earths are planets larger than Earth, but smaller than gas giants like Neptune and Uranus. They can be composed of gas, rock, or a mixture of both. Their masses typically range from twice that of Earth to several times more. One notable example is Proxima b, a super-Earth exoplanet, meaning it orbits a star outside of our solar system. Although the first hints of exoplanets appeared as early as 1917, it wasn't until 1992 that astronomers confirmed their existence, stunning the scientific community. Another planet, first detected in 1988, wasn't verified until 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems hosting multiple planets. Many of these orbit M-type stars, the most common type in the Milky Way. M-type stars, also called red dwarfs, are the smallest main sequence stars. Their relatively cool temperatures, around 3,000 K, and dim glow make them difficult to detect despite their abundance. Proxima b orbits one such star, Proxima Centauri, which has about 1.07 times Earth's mass. Unlike Earth's 365-day orbit, Proxima b completes an orbit in just 11.2 days due to its close proximity, about 0.045 to 0.056 astronomical units, AU, from its star. Proxima Centauri emits only 1.6% of the sun's visible light and produces about 5 to 6% of the sun's total visible luminosity. Over 85% of its energy is released as infrared radiation, giving Proxima b a vastly different environment than Earth. Discovered in 2016, Proxima b quickly became a focal point of astronomical research. Why? Because it's the closest known exoplanet to Earth, located just 4.2 light-years away. While this is still a vast distance, it's remarkably close on a cosmic scale. Proxima b is part of the Alpha Centauri triple star system, one of the brightest systems in our night sky, just behind Sirius and Canopus in visibility. What makes Proxima b especially intriguing is its location in the habitable zone, the region around a star where liquid water could exist on a planet's surface. This raises the exciting possibility that life might be able to exist there. Because of this potential habitability, Proxima b has become a prime target for further exploration. This is where the James Webb Space Telescope, JWST, plays a crucial role. The JWST was launched with 4 main objectives: to study the light from the first stars and galaxies formed after the Big Bang, to explore how stars and planetary systems form, to understand the evolution of stars and planets, and to investigate the origins of life. With its powerful instruments, the JWST is helping astronomers analyze exoplanets like Proxima b in unprecedented detail. It is not only advancing our understanding of planetary systems, but also contributing to the broader quest to detect signs of extraterrestrial life. This pursuit is more than a scientific endeavor. It reflects our enduring human curiosity. For centuries, humans have sought to explore, to question, and to understand the universe. This drive has led to ambitious projects like SETI, Search for Extraterrestrial Intelligence, an effort often compared to a game of cosmic hide-and-seek, as we scan the sky for signals from intelligent civilizations. The modern search began in the 1960s when astronomer Frank Drake detected unusual radio signals from space. While those signals didn't lead to direct contact, they sparked a lasting interest in discovering life beyond Earth. Despite setbacks and false alarms, advancements in technology, especially tools like the JWST, are bringing us ever closer to answers. As the telescope continues to observe exoplanets, such as Proxima b, scientists hope to uncover the first concrete signs of life beyond our world. If successful, such a discovery could profoundly reshape our understanding of life in the universe. The discovery of intelligence beyond Earth, or even just artificial signals or mysterious light from distant worlds, could profoundly reshape our understanding of the universe. Even without direct proof, such findings would imply that intelligent life may be far more common than we previously believed. While the excitement surrounding such discoveries is undeniable, they also prompt deep and challenging questions. How would humanity react if we confirm the existence of extraterrestrial life? Would we meet this revelation with curiosity, respect, and scientific integrity, or would it ignite fear and uncertainty? History has shown that humanity's response to paradigm-shifting discoveries, especially those that disrupt entrenched beliefs, can be unpredictable. This uncertainty raises pressing ethical and philosophical considerations. If we were to encounter intelligent extraterrestrial life, what responsibilities will we bear? What moral framework should guide our interactions with other life forms, whether microbial or technologically advanced? These are no longer abstract questions. As our exploration of the cosmos advances, they will increasingly define our place within it. Standing at the edge of potentially transformative discoveries, the issues of ethics, responsibility, and cosmic perspective take center stage. Encountering life beyond Earth, particularly intelligent life, would be among the most significant events in human history. It would challenge the very foundations of biology, philosophy, and our self-conception as a species. How we approach such a moment will shape not only the trajectory of scientific exploration, but also the nature of our future relationships with other civilizations. Beyond ethics, there are also practical concerns. How do we ensure that our contact with alien life respects their autonomy, culture, and environment? Could our mere presence, perhaps even through remote observation, cause unintended harm to fragile extraterrestrial ecosystems or societies? Just as we've learned that human activity can dramatically impact Earth's ecosystems, we must consider the possibility that our reach could disrupt life elsewhere in the universe. These questions extend far beyond the realm of science. They touch philosophy, politics, and culture. The discovery of intelligent life would likely spark intense global debates about cooperation, potential conflict, or even colonization. How should we prepare to meet beings whose way of life and thinking may be incomprehensibly different from our own? Would such a discovery unite humanity in wonder, or divide us as competing ideologies vie to define its meaning? As we explore deeper into space, international collaboration will become increasingly essential. The search for life on other planets, the study of exoplanets, and the analysis of artificial signals must transcend national borders. Just as the International Space Station has demonstrated the power of global cooperation, so too could the search for extraterrestrial intelligence, SETI, become a unifying mission for humanity. This pursuit of knowledge is not just a scientific endeavor. It is a human one, demanding openness, humility, and shared purpose. At the same time, we must acknowledge that such discoveries may challenge long-standing worldviews. Science, religion, and philosophy may all need to adapt in the face of a new cosmic reality, one in which humanity is not alone, and perhaps not even the most advanced form of life. Such a shift could revolutionize our understanding of consciousness, life, and what it means to belong to a broader community of sentient beings. Ultimately, discovering life beyond Earth will compel us to redefine our place in the cosmos, and possibly our very identity.